Hello everyone, Gaza Mutkash, and I welcome you all to this session on intermediate SQL queries. So guys, let's have a look at the agenda for this session. The agenda for this session includes understanding advanced subqueries and also implementing correlated subquery. So guys, till the previous session we have let's say discussed and implemented let's say the intermediate SQL topics such as joins and subqueries, and also we have discussed let's say group by, having, and order by. So let's proceed with this current topic. So I'm switching to the workbench. So guys, over here we are in the workbench. So in the previous session we were working on this data set. I'll show you the schema. So this is the schema that we have, right? This is the schema that we have. We have two tables, namely employee and projects. For the employee table, the columns that I'm having are employee ID, employee name, department, job role, city, joining date, and salary. And for the project, I'm having project ID, employee ID, project name, start date, end date, and the status. These are the columns. And because these are the two related tables, so the common column between them is the employee ID. Using employee ID, I can connect these two tables. So considering this, we will be discussing the advanced subqueries. So advanced subqueries involves, let's say, subqueries involving multiple tables, and also let's say subqueries in maybe from, join, and having clauses. And we'll also be discussing the correlated subqueries. So these are the three topics that we'll be prioritizing for this session. So let's get started. So over here, first let's understand the concept of correlated subqueries, right? First, we'll be focusing on the correlated subqueries. So correlated subqueries means, now prior to this, all the subqueries that we have seen, prior to this. So these are the subqueries, let's say, that do not operate independently. So why is it the case? Because they are dependent on the parent query. That is why they do not operate independently. So prior to this, all the subqueries that we have discussed, be it let's say single row, multiple row, or even multiple row, multiple column subquery, all the subqueries that we have discussed and covered so far, they can operate independently. Means we can execute the subqueries independently. For instance, if I want to execute this, so I can execute this without its any dependency on the parent query. See, if I execute this, I'll get the result, right? So means subqueries can let's say operate independently, but this is not the case when it comes to correlated subqueries, because the inner query has some dependency on the parent query. All right, and these are the most let's say complex types of subqueries that we can come across. So not every query is a correlated subquery, but let's say correlated subquery is a subset of the subquery, right? Means it is a type of subquery. So they are dependent on the parent query. How do they work? So each row of the let's say inner query, each row of the inner query is compared to the let's say compared to the parent query, and then the data is filtered, and it is only then that the data is filtered accordingly. All right, then the data is filtered accordingly. So this is how let's say the correlated subquery works. So I'll give you an example. So first of all, let's identify. First, let's solve. We do have these two tables, right? We do have these two tables, and we'll be using subquery with joins as well. So in these two tables, suppose I want to find first, let's identify the department wise average salary. So over here, if I were to determine department wise average salary, so how do I proceed with this? So department wise average salary nikalne ke liye, I can simply write like this: select department, and then I can mention over here we have the average salary from the table name is employee, and then I'll be writing group by department. This is what I'll be writing to find the department wise average salary. And maybe for the average salary over here, I can mention average salary as the alias name. So if I were to run this, what am I getting? So for each of these departments, this is the corresponding average salary that we have, right? This is the corresponding average salary. So this is the department, this is the average salary that we have. We have IT, HR, finance, marketing, and sales, and these are the corresponding average salary. Now, my question, let's say, based on the correlated subquery is, for each department, find the employee details whose salary is greater than the average salary okay, let me put it this way. Find the employee details. Find the employee details whose salary is greater than the average salary for employees belonging to the same department. Alright, so means for each department, this is the average salary of the employees. Now, what I want to determine is the employees whose salary is greater than this salary from the same department. Means from the IT department, I want to filter all the employees whose salary is greater than 75,000. From HR department, I want to find all the employees whose salary is greater than 44,000. From finance department, I want to find all the employees whose salary is greater than 75,000. From marketing department, I want to find all the employees whose salary is greater than 81k, and same goes for the sales. So for sales, I'm interested in finding all the employees whose let's say the average salary is greater than 56,000. So this is how, let's say, the correlated subquery logic has to be framed. So we do have the select star from employee. This is the data that we have. This is the data that we have, and we have 9 rows. We have 9 rows in total. All right, this is what we have. And then based on this data, if I were to let's say capture this, so how would I write? Over here I'll be writing select star from employee 1, and I'm calling it E1. All right, I'll be calling it E1. So this is E1. What is the condition where the salary is greater than, where E1 dot salary is greater than, then over here I'll be writing select average salary. I'll call this E2 dot average salary from employee 1 E2, where E1 dot department is equal to E2 dot department. So just try to understand how we have written this query. Over here I'm fetching all the employee details where the employee salary is greater than the average employee salary from the employee table 1, which is I've aliased it as E2. So E1 and E2 are the same tables. I've taken 2 copies. Where what is the joining condition? Where E1 dot department means the department of the employee from the E1 or the parent query is should match with the let's say E2 dot department, that is the department column from the E2 table, right, which is again nothing but the employee table. So over here basically we are comparing each row of the parent query and the corresponding row in the inner query, and only when there is a match in the department, when E2 dot department parent query let's say parent query department matches with the child queries department, only then the average is computed for that department. And then we are filtering the parent query salary with the average salary for that department. So this is how the correlated query works. So we'll check. Okay, I'll show you. So prior to this, we have written this, right? Okay, let me write this over here. So for IT, what is the average salary? It is 75k. I'm writing it in K terms. For HR, it is 44k. Then for finance, it is 75k. For marketing, it is 81k. Then for sales, it is 56k. So this is what we have. Right? We have IT, HR, finance, marketing, and sales. So if this is what we have, let's execute this and check. So the objective should be to obtain the employee details where the average salary is greater than these average salary for the same department, for the corresponding department, right? So let's check. So if I were to execute this, what am I getting? For IT, the average sales was 75k. So I needed to fetch all the employee details in the IT department whose salary is greater than 75k. So for IT, the salary is 85,000, which is correct. For HR, the requirement was greater than 44k. Over here, I'm getting 54, which is correct. For finance, the requirement was 75k. Again, I'm getting 85, which is correct. and for sales this average salary was 56k. So now what I have is 65,000, right, which is also correct. So means this is how we can fetch or implement the correlated subquery. So this is one such example. Maybe besides this we can count. So over here what have we implemented? Find the employee details, right? So instead of employee details I can also write let's say find the count of each department, find the count of, find department wise count of employees. First of all I'm solving this question. So let's check this. Department wise count of employees would be, select department wise count of employee ID, maybe this is employee count from the employee table, and then I'm writing group by department. All right, and next I'm writing group by department. So this is what we have. This is what we have. All right, now my objective is, see, just the way we have solved the previous query, right? Now I want to find for each department, find the count of employees whose salary is greater than average salary of employees in the same department. So again this is a case for the correlated subquery, right? So what needs to be done? So I need to find a department wise count of employees. I need to find department wise count of employees, group by department. All right, now what is my condition? Having this employee count, greater than, so what condition are we trying to match? We are trying to match the condition where let's say the count of employee ID. So over here I'll call this let's say this is employee 1. The table name is employee 1, right? Yes, it is employee 1. So this is employee 1. So I'll call this E1, and this would be E1 dot employee ID. This is again E1 dot department. This is again group by E1 dot department, and having employee count. So having employee count greater than E2 dot employee count from employee 1 E2. All right, where what is the condition? Where the department E1 dot department is same as E2 dot department. So employee count I'm matching, right? I'm matching the employee count from the count where what is the condition? Let's check if this works, otherwise we'll make some modifications. So see, this works, right? We know that this works. Yes, this is working. So now we have to filter this. Let's see if see, this won't work independently. So let's see if this is working. So guys, currently I'm getting empty, means there is no data to begin with. So let's identify how and why. So this is what we have, right? So essentially we can solve this question from let's say this output as well. We can solve it even from this output. So let's skip this approach. Let's try to solve it using this this solution. Now from the output obtained over here, maybe we can find the department wise count of employees, because from each department we are getting only one. All right, so instead of greater than, let's say what if I were to solve less than, or let's say less than the average salary of employee in the same department, right? So currently means this question was for greater than. Now I'll take this up. This is the department. So what I'm trying to solve is less than. Greater than we have already solved over here. So this is the question for less than. So if I were to figure this out, see, this is what I'm getting. Now if I were to check this, for each department, for finance we have one record, for HR we have one, for IT we have two, for sales we have one. So this is the count that I need. So I'm ignoring this approach, rather I'm sticking to this. And from this, what can be done? Again, I'm wrapping it up in the subquery. So because I'm wrapping this up in the subquery, so I'll have to give some alias name dt, because I'll be using this in the from clause, right? So over here I'll be writing select, and this is an example of correlated plus nested subquery, right? Correlated plus nested subquery. So select, what am I selecting? Select, let's say department wise count of maybe department as maybe employee count. All right, as employee count from this table, and then maybe I can write group by department. So what is this going to return? This is simply going to return department wise count of employees whose salary is less than the average salary of all the employees in the same department, right? So for each department, find the count of employees whose salary is less than average salary of employees in the same department. So for finance we have 1, for IT we have 2, for sales we have 1, for HR we have 1. So this is how we can solve the question, and this involves not just correlated subquery, but this involves nesting as well. So guys, this is how let's say we have implemented the nesting part. Next we can look at maybe, let's say, subqueries involving joins. So over here we have subqueries involving joins. So let's see how this works out. So let's have a look at the table structure. So this is the table structure that we have, and as far as this table structure is concerned, we have the employee details and then we have the project details, right? So based on the employee and project details, what are we trying to capture? Let's check. So maybe I want to know the project name. Okay, first of all, let's try to solve some simple questions. Find the project details of all the employees working in maybe IT and finance. All right, so what can be done? Select star from the projects one table. All right, where what is the common column? Where employee ID in. We do have the employee ID, right? So from the projects table, select star from projects where employee ID in, and then I can start my subquery. So my subquery would be select employee ID from the employee table where the department should be in IT and finance. Department should be in IT, and we can also have it in finance. All right, so let's see. So I have to add another bracket to close the query. So these are the, let's say, project details where the department where the employees who work in these projects belong to either IT or they belong to the finance domain, right? So these are all the project details. Let's have a look at a couple of other examples. So now I want to find the project details of all the employees working, maybe of all the employees, maybe let's say whose salary is greater than maybe let's say 80,000. This is what I want to figure out. So again, we can use the same approach. So over here, what am I going to write? Select star from projects where employee ID in, next I'm writing select employee details from the employee table where salary is greater than, where the salary is greater than, what is my condition? My condition is 80,000. All right. So let's see. This is what I'm getting, right? This is what I'm getting. So we just have 2 employees whose salary is greater than 80,000. So if I were to change this to 70,000, maybe see over here I'm getting 3 employees, 3 different projects. So I can change this. So guys, this is what we have. Now I'll show you examples of let's say subqueries in join clause, right? So maybe one I can show you in MySQL, the others we'll see in Postgre. So subquery in join clause, we have solved this question. The first question from the subquery, we'll solve it using this is what we are going to solve using this one, using the join clause. So let's have a look. So this was my original problem statement. I want to find the details of employees having the maximum salary. Now over here I'll be writing let's say select star from employee 1 E1, all right, and then join. Now in the join I can write select employee 1 E2. All right, now over here I'm not interested in writing let's say select max salary as max salary, right? Max salary as the max salary. Let's call this E2 dot max salary from employee E2, and we have to give it an alias name because it is a table, so I'm giving dt on what is the joining condition where E1 dot salary is equal to dt dot salary. So let's see this unknown column dt. Okay, dt dot max salary. So guys, as we can see, now we are able to capture the employee with the maximum salary, right? So this is another approach using which the same query can be solved, but over here instead of utilizing the direct query, I've utilized the subquery in the join clause. So guys, this is how this can be implemented. All right, this is how we have implemented this. Now moving forward, so guys, now let's switch to the Postgre. So we'll see a couple of examples in Postgre. So guys, over here we are. So to consider different advanced queries, over here we'll be looking at, let's say, we'll be discussing, let's say, advanced queries and the correlated subqueries, right? Over here for this data set, we'll be using a couple of more advanced subqueries, and the table structure that we are considering is this one. So we do have the customers and orders tables, the ones that we have been using as far as this particular topic is concerned. So this is the table structure that we have. We do have the customers table. All right, this is my customers table. I'm having customer ID, customer name, city, gender, email, and job, and then we have the orders table with these details. So order ID, customer ID, order date, product name, quantity, and price. So let's have a look at the subqueries and joins. So I want to find distinct customers who ordered products that were also ordered by Priya Verma. So Priya Verma is one of the customer. So over here, what can be written? Over here, I'm writing select distinct customer name from customer 1C. Join orders 1 on C dot customer ID that matches with O dot customer ID. And then I'm joining select the product name from orders where the customer ID is equal to select customer ID from customer 1 where the customer name is Priya Verma. Now, because I've written it in the join, so over here I'm writing as PV products. This is the alias name for the join. And next, because I'm joining this, so I have to ensure that the product is same. So the products that were let's say ordered by Priya Verma should match with the outer query, right? So on P dot product name should match with let's say PV products dot product name, and where the customer name not equal to Priya Verma, because I have to filter out the other customers, right? So that customer should not be the Priya Verma. So this is how we can incorporate this. So let's run this. So we have let's say 4 different customers who ordered the same products that were ordered by Priya Verma. So next, let's try to solve another question. So find average spend per city only for cities where customers have ordered more than 5 products in total. So again, this is going to be a long query. So over here I'm writing select city wise average total spent as average city spend. From in the from clause I'm writing the, let's say, the subquery. So from c dot city, c dot customer ID, and then sum of ordered quantity into ordered price, this would be my total spend, right? From the customers table, join orders 1 on c dot customer ID is equal to o dot customer ID, and then I'm grouping by city and the customer ID. So this I'm calling it as the subject, or let's say sub. This is the subquery group by city. In the having clause, then I've mentioned select some quantity from orders where o2 dot customer ID should match with this subject table customer ID, the subqueries customer ID. These two should match. All right, and this should be greater than 5. Only once it is greater than 5, then the problem statement or the given problem statement requirement is matching. So इसको run करते हैं. So let's see what are we getting over here. Over here I'm getting these 3 records, right? So for Delhi, the average city spend is 70833. For Mumbai it is 24300, for Pune it is 16,000. So this is what we have. Next we have the subquery in having. So what are we figuring out over here? Let's understand the problem statement. So find the customers who placed more orders than the average number of orders per customer. So how can this be done? So who placed more orders than average number of orders per customer? So customer wise, customer name, and then count of order ID as the order count from customers table, and then I'm joining it with orders. So based on customer ID and customer orders dot order ID. So over here, because I'm using the customer ID and name, so I've fetched it from the customer table. But as far as the order ID is concerned, I have extracted it from the orders table. So I've applied the group by. So this is the grouping part. But what is the count? The count should be greater than the average number of orders per customer. So having count of order ID, this part, it must be greater than average order from. So over here I've mentioned average order from, and then again a subquery. Select customer ID count star as orders from orders 1, group by customer ID as subquery. So let's see what are we getting as the output. The output that I'm getting over here is this. See, customer ID to Priya Verma made 3 orders, Manoj Desai made 3 orders, Karthik and even Amit made 3 orders each. Alright, so this is another example. Now I want to show all products with total sales amount that is above the product sales. So this is a simple example. So over here I'm writing select product name, sum of quantity into price as the total sales. From orders, group by product name, having the sum of price into quantity that should be greater than select average of price into quantity from orders 1. So this is let's say the simplest example to demonstrate how we can write maybe subquery in the having clause as well. So if I were to execute this, this is the result that I'm getting. This is my result, right? For smartphone, it is 6 followed by 4 zeros. For tablet, it is 90K. For monitor, it is 88K. For laptop, it is 260K. This is what we have. Next, the problem statement is find average spend per city only for cities where customers have ordered more than 5 products in total. So I guess this is what we have already implemented in the beginning. This is what we have implemented over here. So it's a repetition. So we can skip this. Next, next we have another problem statement. Get average quantity per product and filter only those with average quantity. So over here I'm writing select product name comma average city from, this is the table name, average quantity from orders where the average quantity is greater than 1, right? So over here I have to complete the question where with average quantity greater than 1. So this is what I'm filtering over here. So let's execute this and check. So guys, this is the result. This is the result. For smartphone, the average quantity bought is 1.5. For mouse, it is 3. For tablet, 1.25. Wireless earbuds, 3. Keyboard, 1.66. Monitor, 2. And power bank, 1.66. So moving forward, we can then proceed to the correlated subqueries. So again, over here, I do have, let's say, a couple of examples. So we have already discussed the concept of correlated subqueries, queries that don't execute independently and they are dependent on the parent query. So the first example is find customers who placed an order with quantity greater than the average quantity of their own orders. So let's see how to execute this. Select c.customer id, c.customer name from the customers one alias -c where exist. So if the inner query returns some output, exist implies if the inner query returns some output, select one from orders O where o.customer id is equal to c.customer id. This is where I'm joining the two tables, and order.quantity, quantity should be greater than average order quantity, right? So select average quantity from orders 1 O2 where o2.customer id should match with c.customer id. So when only when these two conditions are satisfied, then the problem statement is resolved or solved. So guys, this is what I'm getting. These are the customer IDs and these are the corresponding customer names, right? Next, moving on, we have the next question. So to find orders whose quantity is greater than average quantity of that product. So again, the very basic example of correlated subquery. So select o1.order id, o1.product name, o1.quantity from orders 1 o1 alias as o1 where o1.quantity is greater than select average o2.quantity from orders 1 o2 where o2.product name should match with o1.product name. So this is simply product wise average where let's say the quantity is greater than average quantity for that product. So let's execute this. So this is what we have. All right, this is what we have. We have order ID, product name, and then we have the quantity. Next, we have to list customers whose total spending is more than the average spending of all the customers. So let's see this. Over here, I'm having c.customer ID, c.customer name from the customers 1c, where select sum of quantity into price from orders 1o, where o.customer ID matches with c.customer ID, and this is greater than. I'm writing another subquery. Select average total spent from select customer ID comma sum of price into quantity as the total spent. All right. From which table are we fetching this? We are fetching it from the orders table, and we are grouping it by the customer. So we are grouping it by the customer, and then I'm calling it as average subquery. So see, in the where clause I've written two different subqueries. This is the first subquery, and this should be greater than the second subquery, and whatever is being filtered, that we are extracting over here. So let's execute this and check. So guys, this is what we are getting. So for the customer IDs, these are the customer names. And what was the requirement? So these are the customers whose total spending is more than the average spending of all the customers. So this could have been done. Let's say we can also implement this with slightly less lines of query. So guys, that brings us to the end of this session. So let's switch to the PPT. So guys, in this session, we have understood the different types of advanced subqueries, including nested subquery, including subqueries involving joins and having subqueries in the join and having clause, and even in the from clause. And we have also implemented and understood the concept of correlated subqueries. So in the next session, we'll be connecting SQL with Excel. Thank you.